Hello students, welcome back to our channel. Today in this video we are going to see Tamil Nadu State Board syllabus, class 12 physics, unit 2 current electricity. Today we are going to see the ninth derivation of this series. This is the part 9 of this video series. Come on, let us continue with our lesson. Question number 9. Explain the method to find the internal resistance of a cell using potentiometer. Answer. Now let us have a closer look at the diagram. So first of all you need to draw a neatly labeled diagram of this kind. So here comes the potentiometer diagram. Here the CD represents the potentiometer wire and the circuit that lies above this wire CD is known as primary circuit, and the circuit that lies below the wire CD is known as the secondary circuit. In the primary circuit, we have battery and a key which is denoted by the letter K1. We have two keys, that's why it is known as K1. And in the secondary circuit, we have a battery and a resistance which is connected parallel to this battery. Again, we do have another key named as K2 over here, and here comes the galvanometer. Next, we do have a higher resistance. From there, it is finally connected to a jockey. This jockey is meant for touching the wire, potentiometer wire from C to D. By keep on touching this wire, we can find the balancing length. The point where the galvanometer shows zero deflection is known as the balancing length. For finding the balancing length only, we use this jockey. Now let us see the explanation. Explanation: primary circuit. BT battery, K1 key, CD potentiometer wire. Then we have secondary circuit. In this secondary circuit, we have epsilon, that is EMF of the cell, capital R resistance, K2 key, capital G galvanometer, HR high resistance. As we have already learned that in an open circuit, we can find the EMF of the cell. So with K2, the key to open, the balancing length Cj is equal to L1 is measured. It means at the point J, the galvanometer needle shows zero deflection. That's why it is known as balancing length. So Cj, this length is indicated by L1, which is measured. And here the EMF epsilon is directly proportional to this balancing length L1. Let it be equation number 1. Then the key 2, K2 is closed and the current is measured. Here the current I is equal to the EMF epsilon by capital R plus R. Capital R stands for the external resistance and small r stands for the internal resistance. Then, as we all know that the expression for Ohm's law, which is nothing but V is equal to IR. In the place of I, let me substitute this value. So epsilon by capital R plus R into this R. So epsilon into R, epsilon R by capital R plus R. Here this expression is nothing but potential difference. So here the potential difference epsilon R by R plus R is directly proportional to the balancing length L2. Let it be equation number 2. Now we are going to divide equation 1 by 2. Divide equation 1 by equation 2. So we have epsilon by epsilon R by R plus R is equal to L1 by L2. So in the next step what will happen? This expression will go here, then gets multiplied. So we have epsilon into R plus R by epsilon R. When this expression goes this side, it gets in reciprocal. So here we need to write the reciprocal of this expression. So epsilon into R plus R by epsilon R is equal to L1 by L2. Here these two epsilons get cancelled. So we have capital R plus small r by capital R is equal to L1 by L2. In the next step, let us write R by R plus small r by capital R is equal to L1 by L2. R and R get cancelled. It becomes 1. 1 plus R by R is equal to L1 by L2. In the next step, this 1 goes this side. So minus 1. So R by R is equal to L1 by L2 minus 1. In the next step, if we take this R this side, it will go up over here. So small r is equal to capital R into L1 minus L2 by minus 1. So we get an expression of this kind. R is equal to capital R into L1 by L2 minus 1. Now let us take the LCM over here. So we get L1 minus, multiply this one with L2. Then we write L2 as common. So small r is equal to capital R into L1 minus L2 by L2. So by using this expression, we can easily find the internal resistance of a cell. So this is the final expression for finding the internal resistance of a cell using a potentiometer. So with this video has come to an end. Let us continue our studies with another video in the next session.
Like, share and comment and subscribe our channel and click the bell button for more videos. Thank you.